In the circuit below, all the bulbs have identical 1 ohm resistances. Each cell in a battery provides a potential difference of 1.5 volts. So 2 cells stacked together will represent 3 volts. Let's find the voltage drop across each bulb. So first thing I'll do is I'll designate the negative terminal here as 0 volts, and at the top of our battery we'll have 3 volts. Let's also label our bulbs R1, R2, and R3. All the resistances are 1 ohm. Let's use the technique of circuit simplification in order to get our circuit down to 1 equivalent resistor. The first thing I'll do is recognize that these 2 bulbs are in series. And so I want to simplify them first into 1 single equivalent resistor. This resistance will still be 1 ohm as it was before, but the new resistance here will follow the rule for series. And so the resistance of bulb 2 and 3 together will be R2 plus R3. That will be 2 ohms. That is R23. This is R1. Next, I notice that these 2 resistors are in parallel, so we want to combine them into 1. And now we have our circuit completely simplified. For any resistors in parallel, we want to use this rule. We have R1 and R23. So let's fill in those numbers. The equivalent resistance of the whole circuit is 0.67 ohms. The potential drop of the REQ should be 3 volts. So we can use the voltage drop and the resistance here to find the current. Let's find the current through the battery. The current through the battery will be delta V total over REQ, which is 3 volts over 0.67 ohms. And it's 4.5 amps. Now that we know this information about the current, what we can do is take that current and assume that it is the current leaving the battery. And it'll be the current in both of these branches here. But according to Kirchhoff's junction law, the current will now split. But now the current will be split into 2 different values, and we have to find what those values are. So let's figure out how much voltage is dropped in each of these resistors. We'll work our way backwards. The whole battery is 3 volts. If we take this path, we're going to go through a resistor and come back to 0. So this resistor must drop 3 volts. If we take the other path and then go through the resistor and come back to 0, we're again going to have to drop 3 volts. So we're actually going to drop 3 volts in both of those resistors. Now that we know the voltage drop and the resistance, we can definitely find the current in that branch. So it's going to be 3 volts over 2 ohms, 1.5 amps. But we also want to find I1, which is the current through the middle branch. And if we divide the voltage by the resistance, we get 3 amps in that branch. So let's write down all the details that we just discovered. The delta V of the middle bulb is 3 volts. The current through the middle branch is 3 amps. That's the current here and here. All right, the current through bulb 2 is going to be 1.5 amps, and the current through bulb 3 is also 1.5 amps. We found the current through the equivalent resistor here, which was I23, and that's actually going to be the current through the whole branch. What we could do now is we could decide to analyze these bulbs individually to find their potential drops. We'll just use their resistance and their current. So for bulb 2, we just have to multiply the current times the resistance to find that this bulb drops 1.5 volts. And this bulb here also drops 1.5 volts. All right, so we filled in what the current is at these different points. We can also fill in what the current is here. That was 4.5 amps. Before we calculate the power of each bulb, can you just look at the circuit and tell how the bulbs will compare in brightness? Take a guess. Which bulb do you think will be brightest of all? To calculate the power, simply multiply the potential drop times the current. So the power of this bulb will be 9 watts. The power dissipated by bulb 2 will be 2.25 watts. And bulb 3 will also dissipate 2.25 watts. That means that bulb 1 is the brightest. One last thing we can do is just label important points with electric potential values. So here we're going to have a potential of 3 volts. And this will be at 3 volts. And these points are going to be at 0 volts. A point in the middle would be at a potential of 1.5 volts.